Hey, welcome to the next video. We're going to be talking about limiting reactants, the idea that sometimes when we run a reaction, we run out of one reactant before we have a chance to use up all the other. And the one we run out first we call the limiting reactant, or LR for short, and sometimes we call it a limiting reagent. And so before we get too far here, I want to bring up a web browser and show you a simulation. So in this simulation here, we're going to practice making cheese sandwiches. And of course, the recipe for a cheese sandwich is 2 slices of bread and 1 slice of cheese makes a sandwich. So let me ask you, if we had 6 slices of bread and we had 4 slices of cheese, how much could we make? And let's see if I can click on the bread. So 1, 2, 3, 4, 5, 6. All right, and 4 slices of cheese. And well, how do we figure this out? Well, we know that 2 slices of bread can make a sandwich. So we know that 6 slices of bread can make 3 sandwiches. We know that each cheese ends up in a cheese sandwich. So 4 slices of cheese should be able to make 4 cheese sandwiches. So all the bread can make 3 cheese sandwiches. All the cheese can make 4. And obviously that's 2 different answers. And the actual answer is we only make 3. We make the fewer of the 2. And the reason for that is that after we use up the 6 slices of bread, there's 1 slice of cheese left over without any bread to go with it. So we say that the cheese is excess. We've got too much of it. And the bread is a limiting reactant or a limiting reagent. We don't have enough of it. It limits how many sandwiches we can make. If we had 2 additional slices of bread, we could make 4 cheese sandwiches, but with only 6, we're limited in how many we can make. So rather than pieces of bread and cheese, we can do the same thing with nitrogen and hydrogen. So for instance, if we have nitrogen and 3 hydrogen going to make 2 ammonias, we might ask ourselves, if we had, say, 10 moles of nitrogen, and perhaps we have 20 moles of hydrogen, the question is, how many moles of ammonia can we make? And to answer this, we actually have to kind of break this down into 2 separate problems. One, we have to say, if all the nitrogen is used up, how much can we make? So we've got 10 moles of nitrogen, and we know from the balanced equation that every mole of nitrogen makes 2 moles of ammonia. So that gives us a prediction that we would make 20 moles of ammonia. And then we do the same thing for the hydrogen. And the hydrogen, right, we say we've got 20 moles of hydrogen, so we got a lot more hydrogen, right? So it looks like we're doing pretty good there. But the thing about hydrogen is it's used up in a 3-to-1 ratio. So 3 moles of hydrogen are used to make 1 mole of ammonia. And just look at the coefficients in the equation to get that. And so that gives us, well, let's see, that gives us 6 2/3 of a mole of ammonia. So the question is, how much do we actually make? Well, just like the cheese and bread making sandwiches, we only make the smaller amount. So in actual fact, in this problem here, this is what we actually make. This is called the theoretical yield. And it's theoretical because, just like making cheese sandwiches, you can drop one on the floor and lose them. In chemical reactions, there are side reactions. You can lose the product. It can go somewhere else. It can react another way. And because we can only make 6 2/3 moles of ammonia, that means that the hydrogen was the limiting reactant. So it limited how much we could make. And we had loads of nitrogen. We had enough nitrogen to make 20 moles of ammonia. So we have, after 6 2/3 moles of ammonia, we've run out of all our hydrogen. We've got leftover nitrogen. So the nitrogen is said to be the excess reagent here. Just like in the last example, the cheese was the excess because we had it left over. So that is how we apply this idea to chemical equations. All right, so here's a test for you. So let's say we've got this chemical reaction here, the combustion of methane and forming carbon dioxide and water. And let's see, when we balance it up, we need 2 waters, and we need 2 oxygens, and we need 1 CO2. So that's perfect. So my question to you is, how much CO2 can we make if we have, say, 2 moles of methane, and we have, say, 5 moles of oxygen? So how much CO2 can we make? And which one is the limiting reactant and which one is the excess? So pause the video and have a go, and then we'll come back and check it out here in a second. All right, so how do we do this? And the way we do this is we're just going to use the coefficients. We know that 1 methane reacts and forms 1 CO2. So we can go ahead and write that there. That's a 1-to-1 relationship. So 1 mole of CH4 makes 1 mole of CO2. So we can see those units cancel. And that is a prediction that we will make 2 moles of carbon dioxide. Now, what about the other thing, the oxygen? So 2 moles of oxygen make 1 mole of CO2. So we can go ahead and say 2 moles of oxygen are used up. And in doing so, we make 1 mole of CO2, and that gives us 2.5 moles of carbon dioxide. So units cancel. So how much do we actually make? So we go by the smaller. So clearly we can't make any more than 2 CO2 moles. Otherwise we run out. So the methane then was the limiting reactant or limiting reagent, and the oxygen was in excess. So we had too much oxygen. Sometimes we want to figure out how much left over. So imagine we had a problem and we wanted to say how much left over oxygen. Well, we can kind of go backwards and we can say if we know we make 2 moles of CO2, where did it come from? Well, the CO2, right, came from oxygen in that 1-to-2 ratio. So we can kind of go backwards and say for every 1 mole of CO2 that we formed, we must have used up 2 moles of oxygen. So we can see 4 moles of oxygen were consumed. So if we had 5 moles of oxygen at the start of the day and 4 moles were used up, then we can go ahead and we can say the remaining is just what we started with minus what we used up. So we can see that we would have 1 whole mole of oxygen remaining